So number 5 in 8.3 is sine of 2x equals negative square root 3 over 2. So the first thing we need to do here is we need to get that 2x substituted. So we're going to say we'll let u equal 2x. Alright, so our new equation is going to be sine of u is negative square root 3 over 2. So to get u by itself, we're going to take sine inverse of both sides. The sine inverse of sine undoes the sine itself, and we're just left with u on the left side. That's why we do the sine inverse. The sine inverse on the right side, negative square root 3 over 2 means, alright, sine inverse. We have two quadrants we're working with. In inverse trig functions, we're always in two quadrants, one positive and one negative. So we're either in quadrant 1 or 4 for sine. Because we're negative, we're looking at quadrant 4. So what angle gives sine a ratio of square root of 3 over 2? And that would be down here, and this angle is negative. Well, I'll let you take a minute, pause the video, or try and look it up, see if you can figure out what is the sine inverse of negative square root 3 over 2. And your answer is negative pi over 3 here, which is great. We now know that one answer is negative pi over 3. The sine inverse answer to negative square root 3 over 2 is negative pi over 3. That's great, but the catch here is the instructions for this part of 8.3 say find the exact values between 0 and 2 pi. So we still haven't found any answers for the problem. We've just found the sine inverse. So in order to continue, we need to find the angle that starts 0 and comes back around to that reference angle. So in order to do that, we know this little segment right here, negative pi over 3, is the same as saying going around positive direction 5 pi over 3. Alright, take a second if you need to review that. I want to make sure you understand how we went from negative pi over 3 in our sine inverse to our window 0 to 2 pi. That same negative pi over 3 is now 5 pi, positive 5 pi over 3. And I'll write it over here. Okay, and with that, once we know 5 pi over 3 is one answer, let me kind of clean some of this up. We're going to go back, undo these check marks, undo some more stuff here. Okay, so that angle is 5 pi over 3. Our second answer, we have two answers because it's 0 to 2 pi. 0 to 2 pi means two answers. Our other answer is going to come in, well, let me explain here. Sine is negative in quadrants 4 and 3. So we've already found the answer we're looking for in quadrant 4. Now we need to find the angle in quadrant 3. So we're really looking at this reference angle is pi over 3 again. But that's not our answer. Our answer is going to be find the angle, let's go with red again, from 0 to 2 pi. Well, we haven't gone to 2 pi, we've gone 0 to this reference angle. So if we go halfway around the circle, that's 3 pi over 3. And if we go this extra pi over 3 here, our second answer is 4 pi over 3. So believe it or not, we're only about halfway there. And the reason is we've only solved for u. So now we go back and say, all right, u is 5 pi over 3, but that means that u was 2x. So now 2x. Let me bring the screen down a little. Right, u equals those two trig values, but u is also equal to 2x. So we're going to continue both of these. We're going to say that x then equals half of those two values. 5 pi over 3 divided by 2. You get 5 pi over 6. 4 pi over 3 is now 4 pi over 6, which is 2 pi over 3. We have one answer, two answers, but we actually have a total of 4 answers. All right, let me explain this through Desmos quick. Well, I'll give you the two other answers. You're just going to add pi to each one of these. So if we take, let's go over here, 5 pi over 6 and 2 pi over 3. Okay, we're going to add pi to them. We end up getting, in terms of 6's, that's 11 pi over 6 and 5 pi over 3. So here's our other two answers. Now, at this point, we're done with problem 5. All the answers are 5 pi over 6, 2 pi over 3, 11 pi over 6, and 5 pi over 3. How did we get 4 answers? I'm sure at least some of you watching this are wondering, how did we go from 2 answers to 4? And that's where I want to show you on Desmos how we get that. So what I've done is, in my window, you can see here, I've graphed sine of x and negative square root 3 over 2. So if my problem said sine x equals negative square root 3 over 2, I get two answers, 4 pi over 3 and 5 pi over 3. That's what we got when we did our original u, right? Our u values of 5 and 4 pi over 3. But because the period of this graph, let me scroll up a little. Okay. The period of sine of 2x is just 1 pi, 2 pi over 2. So what happens, let me go down to our graph. As soon as I put a 2 in front, watch what happens. I go from 2 answers to 4 answers. And the reason is, our graph repeats itself twice within the window 0 to 2 pi, the window that we're working in. That's how you get 4 answers. We take our original solutions and then we keep doubling them or copying them until we run out of room from 0 to 2 pi. So we could have continued adding a period to our function and gotten, let's see, would that be another, so 17 pi over 6, but that's out of our 2 pi. So again, rewind that a little bit if you need to on the explanation of how we went from 2 answers to 4 answers. But the bottom line is, you find your 2 original solutions, and then you keep adding the period of your graph until you run out of room from 0 to 2 pi.